Welcome to today's presidential lecture. And as you know, presidential lecture means time for inspiration beyond the ordinary, sparking our curiosity. And today this inspiration will be given to us by Professor Ken Ono. And he is a distinguished professor of mathematics with extraordinary, I would say, multi-talented skills and interests supporting all kinds of talents, from a mathematical perspective, of course. He is a STEM advisor and active leader in many professional organizations. And his interest also includes both film and sports. He is it's a true honor for us here at OIST and for me to have Professor Ono with us here at OIST today. And I now actually will ask Professor Spire to introduce our speaker a little more in detail. Would you please, Leon?
Thank you very much, Karen. So as Karen mentioned, Ken is currently the STEM advisor to the Provost at UVA. He also holds a professorship in the maths department. He's the Marvin Rosenblum Professor of Mathematics there. He's had a very successful career to date. He first received his PhD in 1993 at UCLA, and has had countless fellowships and awards, too many to name. Plenty of NSF funding and NSF career grant, and all sorts of great accolades during his career. Serves on the editorial boards for many journals. Is a very busy man, very in high demand, I think. So we're very honored to be able to welcome Ken this week. He's kindly giving 3 talks actually during his brief visit. So it's very nice to have such a kind of prominent mathematician put in, kind of give us so much of his time. It's really nice to welcome him here. In 2005, Ken was named an NSF Director's Distinguished Teaching Scholar. He's a Fellow of the American Mathematical Society, an Honorary Member of the Indian Academy of Sciences, and an Honorary Member of the Romanian Academy of Sciences. He serves multiple leadership roles at his university and more broadly to the mathematical community in the US in particular, but worldwide he has a large impact. So it's really great to have such a prominent speaker here with us today. And finally, what I should mention is I can count on one finger the number of mathematicians I know that, on their CV, they have some mathematical consulting for a Hollywood movie, which Ken will talk about, as well as starring in a Super Bowl advert. So he's really spread himself through many fields. So let's give a warm welcome to Ken, as Ken tells us all about Ramanujan.
Great, thank you. Good morning. I'm really happy to be here. It's a little bit loud. Can we turn the volume just down a little bit? Yeah, so I'm delighted to be here. Thank you for coming. I know that you have other options. It's sort of like getting on an airplane and the stewardess thanks you for flying their airline. So thank you very much for coming here. I will be giving 3 talks. The other 2 talks will be about, well, they're very different. I'm giving a talk this afternoon about number theory. Last year we were runner-up for what's called the National Academy of Sciences Cozzarelli Prize. You may have read about that in the news, about primes and so on and so forth. If you're interested in that talk will be this afternoon. And on Thursday, if you're a sports fan, I'm going to talk about how you can use mathematics, data science, and a little bit of engineering, and certainly a lot of physics to enhance the training of elite swimmers. This is something I've been working with for about 10 years, and I'm very proud to say that 2 of my athletes won world championships yesterday in Singapore, and our program can boast over 100 Olympic and world championship medals since the Tokyo Olympics. And so I just don't understand why other countries don't do that, I love talking about it. So if you were a swimmer, want to see how you might be able to use sensor technology combined with some physics and so on and so forth, I'll be talking about that on Thursday. complete with breakdown of actual swims from a scientist's perspective. Today's talk, however, is quite historical. If you're looking for statements of theorems, I'm going to let you down. This talk is as advertised. Why does the Ramanujan, the man who knew infinity, why does he matter? And through the course of this lecture, our time together, I'm going to give you probably 4 or 5 answers to this question. And my hope is that at least one of those answers actually speaks to you. I want it to be more than you accept the answer, but I want it to be at least some of the answers that speak to you. It's actually quite ironic that I'm here in Japan talking about Ramanujan. As you might know, my last name is Ono. Still Ono. Still Ono. It's like the most symmetric name in the universe. And Ono is Japanese in origin. My parents came to the United States shortly after World War II. And I want that to sink in for a moment. My parents grew up in Japan during World War II at a time when the United States and Japan obviously did not cooperate. These countries, or at least their leaders, probably not their people, but the leaders hated the other. And so what would it be like for Japanese to leave their homeland that was defeated in war and then work in the United States of America where their neighbors despised them? Right? My parents came from this country that bombed Pearl Harbor, and they decided to raise a family in the United States of America. And I want that to sink in. And what might surprise you is that the story of Ramanujan plays a very significant role in how not only did that happen, not only how they immigrated to the United States, but also why I ended up becoming a mathematician. And let me get started. I first learned about the story of Ramanujan when I was in 10th grade, a high school student. This is 1984. I was in 10th grade. I was pretty good at mathematics, but I will tell you, probably in a way that's not very different from probably your upbringings, the last thing I wanted to be in 10th grade was anything my parents thought I should be. Just want to get it out there. The last thing I wanted to be was a mathematician, and my father was a mathematician. For me, growing up, for almost all of the years I was at home, mathematics meant memorization, meant performance and accuracy on examinations. It meant test scores. It meant the mindless pursuit of scores. That's what numbers meant. For me, in elementary school, beautiful numbers were the numbers that were like statistics that baseball players would accumulate, right? But the rest of it, not so much. And the first moment where that changed for me was shortly after, it was Saturday in April in 1984, when the letter that you see on the screen arrived at my house in Baltimore, Maryland, where my father was a professor of math at Johns Hopkins. Let's read it. Yeah, great. All right, perfect. All right, so let's go on. So this letter, which, by the way, my dad gave to me many, many years later, it's one of my most prized possessions. We had it nicely framed. It hangs in my office, and it's a great conversation piece. For many of my visitors who already know the story, they want to see it. And for those who don't know the story, I get to repeat the story. So a bit of an aside, my friend Amir Excel, who passed away in 2015, was so taken by the story, he said, we should put this down on paper. How is it that the story of Ramanujan, as I will begin to tell you, how has it impacted your family and then more generally the mathematics community? And so we wrote this book called My Search for Ramanujan, the subtitle being How I Learned to Count. And that's not pun intended. That's really meant how did I find my way as a scientist by following these various themes and stories that I'm about to tell you. All right. About 10 years ago, a miracle happened. I was a professor at Emory University at the time, and I received an email from a very famous Hollywood producer and director, Ed Pressman and Matt Brown. Sent me an email indicating that they were about to make a film about Ramanujan, and it had come to their attention that I was one of the people that might be enthusiastic with regard to helping out with the project. I am so grateful that I was the very first person that they emailed that responded. I can't imagine what my life would have been like had I been second or third to reply. I wouldn't be here now. I wouldn't have a story to tell. So I'm very grateful. All right. So yeah. We made this film called The Man Who Knew Infinity. I'm going to share some clips with you. If you're interested in films, I can tell you that we are now planning a film about the first woman to win a Fields Medal, Mariam Mirzakhani. Her story is equally compelling. Born in Iran, a woman wasn't supposed to be pursuing mathematics in Iran at the time. And so a lot of, quite amazingly, there'll be quite a few parallels between the story of Ramanujan, international cooperation, and reaching the pinnacle of science. So in any event, yeah, this was us about 10 years ago. I still had my hair. And one of the most exciting things I have ever been asked to do as a mathematics instructor is to try to teach complicated mathematics to an audience that includes Hollywood actors. This is Dev Patel, who was all boy at the time. He had come fresh off a number of films. You might know Slumdog Millionaire. You might know the Best Exotic Marigold Hotel films. And at the time, he was 24, and he was all boy. He might as well have been 17. Also on our cast was the distinguished actor Jeremy Irons. And yeah, definitely will share with you some stories about that. The second answer to the question, why does Ramanujan, the man who knew infinity, matter, is illustrated by this picture. And when I first started giving talks about this question, I never thought that it would be 2025 where the answer to this question I'm about to give you is even more important than ever before. And in particular for this audience, which is quite international, here we are at the southernmost point of the country of Japan, and just by looking around the audience, this is an international audience, right? I imagine that most of the continents are represented, most of the scientific fields are represented, and the spirit, the mission of this institute is that through international cooperation and cooperation among different fields, something good can be done. Am I right? Good. So where is this picture? It probably says, this is a picture in front of the White House, taken in October 2016, 1 week before a pretty unfortunate presidential election. And the outgoing president, Barack Obama, as is tradition in the United States of America, is that if you are an outgoing president, before the presidential election, you hold 1 week of transition events, training the transition teams for the leading candidates about how to be president. That includes how does the White House work? What does NSF do? What does NIH do? How do you communicate with your generals, the Joint Chiefs of Staff? You can't just show up and be president of the United States, despite what some people may think. It takes training. And I wish we could laugh about that, but it takes training, right? And the last day of the transition events that the Obama administration put on in 2016 was a day of science. And I was delighted to be asked to participate on behalf of mathematics with the former NSF director, Franz Cordova. But what this picture is about is the unexpected. Obama had seen our film, The Man Who Knew Infinity, and he said, although I don't really get the mathematics, what that movie tells me is the importance of international cooperation. I know I haven't yet told you the story of Ramanujan and Hardy, and I will get there in a moment, but for many watchers, casual viewers of the film, it was an incredible story about two people who had no reason to, in fact, know each other. They had different religious beliefs. They came from different countries. Everything about them was different. But together, they laid the groundwork of very important mathematics. If you work in string theory here in quantum gravity, my guess is you use their circle method to compute black hole entropies. I bet you do. And little things like, now big things like that were born out of this international cooperation. So what Obama wanted to do to end the transition of events was to have a social event. And he asked us, will you bring the actors and will you screen the film, The Man Who Knew Infinity, on our science day to make that point? And he said, if we were going to overcome climate change, if we were going to make any progress in the search for green energy, so on and so forth. And this is pre-COVID. He said this will require international cooperation. And none of us thought that at all when we made this honestly, little independent film. So the second reason that Ramanujan matters is his story has inspired people of influence as a tool to leverage support in science. And yeah, I wish it was still 2016. Yeah, here we are in 2025, and we really need to not re-engage a movement. We really need to do quite a bit more. So here we are, right before the streaming of the film. We gave a math question to whoever was online watching this on the internet. And here, DJ Patel and I are asking the question, what is the smallest number that is a sum of 2 cubes in 2 different ways? And if you watch the film, you could answer the question. So the important details. Ramanujan was from India. He was born in the late 19th century in lush southern India. If you've never been to India, go, right? You might have to get some vaccinations depending on how fragile your health is, but it's a beautiful country. The people are very kind, and it is incredibly rich in history. Ramanujan was born in the late 19th century in South India. He was born into the Brahmin caste, and he was an outstanding student before he got to college. If you take a tour of India, you can see some of the sites that mark his life, and I encourage that you do that. If you visit his high school, and at the time he was in high school, India was a colony in the British Empire, so he went to an English-speaking high school. In his high school, they will even proudly show you the awards that he won when he was a high school student. He discovered mathematics on his own, and as the story goes, he invented much of trigonometry by himself. All I know is when I was in 10th grade, I wanted to defeat the Atari computer game system. And I would have been incredibly proud of that. I had no idea that people existed that had this sort of level of genius and creativity. Which, by the way, we should be promoting much more now that AI is upon us. The routine, we need to emphasize much more the process of creativity and wonder, and this is something that he had in spades. When he was in high school, a friend gave him a copy of this book called A Synopsis of Elementary Results in Pure Mathematics. It by no means is a very good book. I think its only place in history is because of its connection to Ramanujan. What is this book? It's a book that contains enunciations of over 6,000 theorems, systematically and quite scientifically arranged, with proofs which are often little more than cross-references. What does that sound like? That sounds like a book that a tutor would use a high school student who's preparing for college entrance exams. But he devoured this book. He loved the formulas in this book, and he wanted to prove them or establish them on his own. And then he went beyond that. He wanted to find his own formulas, and he believed that they were gifts to him from his family goddess Namagiri, and he started recording his own findings in his own notebooks. You can go to the University of Madras library and ask the librarian, can I see Ramanujan's notebooks? And you know what? They'll bring them out. It's crazy. I don't know about you, but if I were in the United States and I went to the National Archives and I said, I want to see the Declaration of Independence, yeah, they'd probably open up an FBI investigation, yada, yada, yada. But certainly in the annals of science and annals of mathematics, these are very, very storied books. And they still allow you to hold and flip through the pages. Ramanujan, as I said, became obsessed with mathematics. He was so obsessed with his mathematics, he couldn't concentrate on any of his other studies, so that's why he flunked out of college. I don't invite any of you, if you're in a position to get a degree here, to flunk out, but I think you understand the point I'm making. You can mistake the ordinary rigid process of education with the point of how you become a scientist. Right. And just to add a little bit of color, Ramanujan did a lot of his mathematics inside these massive stone temples in lush South India, and try to imagine Hindu monks chanting and maybe a cow here or there, and some drumming to accompany the, yeah. So although he was a 2-time college dropout, he had friends. And I think this is a great thing. His parents continued to support him, and he found work as a clerk to support himself. He wasn't wealthy. He married his wife when she was 9, and so by day he was a clerk for the Madras Port Trust, and by night he was getting visions from his Hindu goddess, writing down some of the most remarkable formulas. So at the time, nobody could understand his formulas, and in fact, we are still trying to understand his 3 notebooks. There are faculty at the best universities around the world, Harvard, Princeton, you name it, who have been inspired by Ramanujan, and I don't think you could ask anyone who is in the know and have them respond by saying, yeah, we've matched those notebooks. It's one thing to know and check a formula, but it's something completely different to understand when you're seeing a glimpse of a theory. And what Ramanujan was very good at was finding formulas that he found beautiful, and that origin of beauty ends up becoming the beginning of a theory. If you work in mathematical physics, the story of the sum of 2 cubes predates the discovery of K3 surfaces. So if you're searching for K3 in quantum gravity, yeah, I wrote a little paper on how the sum of 2 cubes is really the first example of a K3 surface before any of the mathematicians whose last names begin with K even did any mathematics whatsoever. Great. So I would like to share with you some film clips, because the film clips are far more engaging than me just telling you. This is why you show, not just tell. So let me show you some of the film clips with certain points in mind. So the first film clip I want to show you is very important to me, because we made a film about mathematics. If you go to the theater, you're much more likely to see a film about Superman, or Mission Impossible, or the Fantastic Whatever 4. Right? We made a film about mathematics. So we never expected to get a large audience, but it was important to us to be true to the science, but not get caught up in formulas. So you might ask, how do you make mathematics accessible and beautiful on film? So let me share with you this clip. And Leroy, if you could turn down the lights. So that is Janaki Amal. Obviously, she is not 9. She was played by actress Devika Bisay. We did our very best to tell the accurate story, except that it was not acceptable in Hollywood to have a 9-year-old play a wife. So there are a few places where we stretched the truth, and this was, of course, one obvious one. Great. I hope you thought that was beautiful. I thought the cinematography was well done. So Ramanujan was working in isolation, and he basically had no one to share his ideas with. Think about how horrible that is. I think we all understand how horrible that is. We all came out of COVID, where despite the fact we were connected by the internet, there was a loneliness. And imagine that you couldn't send an email to a colleague across the country or across the globe that shares your interests, because you don't know that anyone like that exists. You'd go mad. So in search of a mathematical friend, Ramanujan started writing letters to mathematicians around the world, and he wrote one letter to G.H. Hardy. And if you're a biologist, or if you took high school biology, the name Hardy is probably very well known to you, of the Hardy-Weinberg law in genetics, right? 1/2 times 1/2 is 1/4, yeah. And Hardy was a very famous analytic number theorist, one of the fields that I love very much. And this letter that Ramanujan wrote to Hardy begins with very famous, beautiful, and humble words. The letter goes, "I beg to introduce myself to you as a clerk. I've had no university education. I've not trodden through the conventional regular course, but I'm striking out a new path for myself, and the results I get are termed by local mathematicians as startling." So with regard to the film, on the right, I show you Jeremy Irons. We asked Jeremy to replicate this very famous pose of G.H. Hardy, and I think he did very well. Jeremy Irons might be an actor that you know, whether you know him from The Lion King or the 50 or 60 other films that he's been in. I'll tell you, one of the most exciting facets of my work with this film was to get to spend time with someone who was a world-class actor. Before this project, I never really had an understanding of how you become a world-class storyteller, from how you manipulate your face. And even in his case, he thinks deeply about how the blood flows through the vessels near the surface of the skin on his face, because he says that that even it reflects his emotion. And I never thought that there would be actors that even thought that way. And in Jeremy, you have someone that is certainly much more than that deep voice that you probably are aware of. Well, a little bit of math. What was what did Ramanujan include in this letter? Well, he included some facts that are well known. He included some facts that were false. And he included some extraordinary claims that were really not quite right, but not wrong either. One of which is this. He wrote that the sum of the positive integers, 1 plus 2 plus 3 plus 4 plus 5, etc., which all of you knew from the moment you could count, goes to infinity. But he said, no. Well, maybe it goes to infinity, but the version of infinity we want to write down happens to equal negative 1/12. And that might look crazy, because at face value, it is wrong. Okay? And it's something like when you work with AI. If AI gives you something that's wrong, don't dismiss it as a hallucination. Study the reasoning trace, because there were some steps that led the AI to get there. Maybe there's something you can learn from having done that. I say that because I have to think about AI a lot at work, probably like all of you. But here, the point I want to make is that when Ramanujan wrote down the equal sign, don't make the mistake in thinking that the equal sign meant to him what it means to you. If I say A equals B, we just agree that A and B happen to be exactly the same. But for Ramanujan to say A equals B, they might not be exactly the same, but there's a very strong relationship. And because paper was expensive and because he had a very good memory, he just had to remember that there was some relationship between them, and he could remember what that was. So if you have taken a course on complex analysis, or familiar with the work of Riemann in connection with the famous $1 million Riemann hypothesis, you know this isn't crazy. There's a process called analytic continuation, invented in the 19th century by Riemann. And if you're familiar with that work, you would know that this isn't actually false if you replace the left-hand side with Riemann's representation for that formula and the process of analytic continuation, which actually gives this number. The equal sign means something else. It means a functional equation. So how was this letter received? Ramanujan wrote this crazy letter with crazy claims, some easy claims. So let me share with you this fun clip of Jeremy and Toby Jones, who played. So there you have it, a letter and the series of letters. The correspondence was so impressive to Hardy that as an Englishman, remember, this was a time of British imperialism. This great professor in Cambridge invited a 2-time college dropout from India to study with him as his personal fellow in Cambridge. And that is extraordinary. Just let that sink in for a moment. It would be very difficult for us today to try to do the same. And people often ask me, what would you do if you met someone with those skills? And I have to admit, the first thing that would cross my mind is, this person is probably a crank, and I don't know that I'm not making a mistake. Wouldn't be making a mistake. So Hardy invited Ramanujan to study with him in England, and this is the very first scene where Hardy and Littlewood meet Ramanujan in his office, the very first meeting. Try to imagine the setting. They've never met yet in person. Ramanujan's from far away India. This is Cambridge, a Don, right? Sadlerian professor. What would that first interaction be like? So the maybe two-part, I actually ended up becoming an associate producer on the film. A lot of the scenes, I had the pleasure and privilege of tweaking together with Matt Brown. And that particular line that you kind of chuckled at was meant to be kind of a wink-wink to me and my friends. Right, here we are in the 21st century, and yeah, many lifetimes for mathematicians have gone by, and we're still studying those notebooks. Yeah, great. So again, the lecture was called, what why does Ramanujan, the man who knew infinity, matter? And I think I've given you a couple questions, but let me just show you this particular scene in the following context. What you just saw in the previous scene is that Ramanujan was a complete foreigner to Littlewood and Hardy, right? You even got that little sense of the racism in there. And you saw that Ramanujan turned out to have many, many more formulas than they had anticipated. He'd only written formulas in the form of a few letters, and here were these notebooks full of formulas. So now I ask, if you are the professor, if you are the thesis advisor, if you are the teacher, how do you deal with that? Because whenever you are the teacher, you're generally accustomed to being in a position where you need to bestow on your student your wisdom. But here we had a situation where the professor knows how the business of science is done, but the student has already eclipsed the professor in creativity and wonder. That doesn't generally happen. This could have gone sideways, right? And I've seen it many times. I'm STEM advisor at the University of Virginia. You see many professors saying, this is how it's supposed to be. And you hear them talking about how they train their students or postdocs in the image of how they were trained. And if there's ever a point in time where this is what we are not supposed to do, it is now. And one of the reasons I want to show this clip with you is that Hardy came face to face with someone far more talented than himself. This could have gone sideways. So let me show you how this was rescued. This is really kind of an amazing story. Didn't start so well. There's so much to it. First of all, it wasn't the Wren Library. That was filmed at Oxford. But if you get the sense that the mentoring relationship between Hardy and Ramanujan was something magical, not just on film, but in the true story, then I am pleased. But we want to take much more from that. Why does Ramanujan matter? We can learn from this. And in fact, a lot of this particular scene is Hardy challenging Ramanujan to justify why the work matters to him. And as a beginning student, he just did the work because it was beautiful, which is often our fallback in the theoretical sciences. The formulas are beautiful, it is elegant. But we live at a time where that's not enough. Right? Our work has to be held accountable. You're going through an exercise tomorrow where your whole institute has to kind of do a similar thing. We're doing that all the time when we're writing our proposals. And the thing is, exercises like that are important, right? I remember when I was a young tenure-track assistant professor, was how do I get my next grant? But it's only with age that I began to realize maybe the grants are required to facilitate the work, but don't lose track of why we are doing whatever it is you happen to be doing in your science. Whether you're searching for new murmurs among the gravitational waves, or whether you're trying to prove the Riemann hypothesis, or finding the cure to some disease, or playing a role in drug discovery. Every success along those lines is important. And I like that in this scene because it emphasizes the role of the student or mentor over graduate students and postdocs as a significant piece that facilitates that. That's why we do our science. I don't think any of us do our science to be rich. If we did, that's a low bar, right? Okay? But isn't it exciting when you get your finding? Maybe you get a paper published in the top journal. Maybe that's exciting, but I hope not. I hope it was that work itself that mattered more. And if it doesn't, focus and maybe recalibrate there. Excellent. Great. So glory and tragedy. In his time in England, Ramanujan wrote 30 papers, some with Hardy. As you got a sense from the clips I shared with you, he overcame racism and the difficulties of World War I to do this. Cambridge was transformed into a hospital for British soldiers returning from the front. So all of this work was done amidst the death and destruction of war. Ramanujan, as a Brahmin, was vegetarian, so he couldn't eat the English food. That's kind of ironic, right? You go to England now, there's no such thing as English food. It's actually Indian food. But that wasn't what it was like at the turn of the century, 19th to 20th, so it was very difficult for him. Despite all of these challenges, Ramanujan was the first Indian scientist to be elected Fellow of the Royal Society. That is a big deal. He was elected at the age of 30. He was elected in the year 1918. In 2018, just a few years ago, Venki Ramakrishnan, who you may know, he was the president of the Royal Society. And if you're a chemist, you know him for his work on mRNA. He won the Nobel Prize in Chemistry for it. But I learned from him, we've become friends, that Ramanujan had inspired him. He had come from lush South India as a boy, and he wanted to replicate the story of Ramanujan in his life. Well, he ended up winning a Nobel Prize, and when he was president of the Royal Society, he said, I am going to see to it that the Royal Society and Cambridge University recognize the 100th anniversary of Ramanujan's election as a fellow. Just think about the fellows of the Royal Society, Newton, Rutherford. I mean, they don't have the time to celebrate all the great scientists that have been elected fellows in the annals of that great society. But they chose in 2018 to celebrate him. And I thought that was amazing, and mathematicians and physicists from around the world, including Oguri, by the way, we descended on London, and it was a great celebration. Ramanujan became sick towards the end of his stay in England. He was misdiagnosed. He returned to India in 1919, hoping for a return to health, but that wasn't to be. He died in April of 1920, and he was just 32 years old. Despite the fact that he was dying on his deathbed, he continued to do his mathematics. Janaki Amal, his widow, cared for him, and she told stories about on his deathbed he would continue to do his sums. And to her credit, she saved the pages, had them forwarded to England, and these pages found their way into the Trinity College Library. To be forgotten, not lost. They were later rediscovered in the 1970s and called the Lost Notebook. I hate that terminology. I've met the librarians at Cambridge. They never lost it. It was in perfectly good care. It was a forgotten notebook. And what were some of the things that were found? Well, one of the things that was found is this theory of mathematics called harmonic Moss forms, where if you're familiar with the work of Jeff Harvey or Simon Donaldson or Witten, at the interface of string theory and algebraic geometry and number theory, you'll know that about 10 years ago there was a huge flurry of activity, as a number theorist, I was one of the people to think about the distribution of black holes in a particular type of string theory, and our method for proof relied on the work that Ramanujan wrote down on his deathbed. So I'm beginning to wrap up here. I feel like the need to include a little bit of mathematics. So let me have fun with you. And the mathematics I'm going to talk about here is very close to the kinds of objects that Liron here at OIST works on, and he's one of the world experts in the field, at least in direction of representation theory, a very large area in mathematics. So what looks like child's play becomes the bread and butter for mathematicians in many different kinds of fields. And one function you might study is called the partition function, P of n, which really looks like just the stuff of adding and counting. There's a function P that counts how many ways you can assemble the argument as sums. So if you take 4, there are 5 ways of making the number 4 from sums without reordering. Count them up. So P of 4 is 5. And Ramanujan loved this function. If you were ever bored in a lecture, try to confirm that the number of partitions of 32 is really 8,349. I help you. The first one is 32. The second one is 31 plus 1. The third one is 30 plus 2. And if you get all the way down to 32 copies of 1 added together, if you didn't make a mistake, yes, there are 8,349 of these. Now, I don't want to have to justify that this function is very important, although I've already made that. What Ramanujan together with Hardy did is they got a very closed formula, almost closed formula. It's called an asymptotic that reflects the growth of these numbers. You're probably wondering, why was Ramanujan the man who knew infinity? So I'm going to tell you. This is why I'm going through this. Together with Hardy, Ramanujan proved that P of n is asymptotic to 1 over 4n root 3 times e to the pi root 2n over 3. the stuff of adding and counting, if you want to estimate how many ways there are of doing that, you cannot escape needing to know these ugly transcendental numbers e and pi, which, by the way, if you have to denote a number by a simple Greek letter, the theorem is that it's a naturally nasty number. It's not like 5 or the square root of 7. And here I have e to the pi, then raised to various powers depending on n. This is really a very subtle kind of special function. But what they proved is P of n is very close to the expression on the right when you plug in for n. It is never equal. If you subtract the left-hand side from the right-hand side, they are never equal. But what the theorem says is if you divide the right-hand side into the left-hand side and plug in larger and larger values for n, that converges to 1. So if you want to know why Ramanujan is the man who knew infinity, he was the person who discovered an asymptotic formula which in this sense gets more perfect the closer you get to infinity. Isn't that cool? Okay, so it's not, let's make up something that sounds sexy. Ramanujan's the man who knew infinity. No. That actually has as its origin this mathematical concept, and I like that. All right, so let me begin to wrap up. This theorem is not just about the partition function P of n. There are mathematicians who work in harmonic analysis who use the method that they developed to prove this theorem in their bread and butter in mathematical physics. If you do some asymptotic analysis, I'm sure the circle method is in your toolkit as well, and that has its important origins in this work. What else do we learn from Ramanujan? Why does he matter? Well, we wouldn't be talking about him if his mathematics didn't matter. So I told you about the stories of his work when he was alive. Perhaps the best measure of how important Ramanujan is the mathematics that was born out of trying to understand what he left in his notebooks. So every Fields Medal in representation theory, algebra, and number theory, almost everyone, somehow has input from Ramanujan's notebook. The Fields Medal is our Nobel Prize. It's given out every 4 years, and it's a major honor. So yeah, I list some for you. If you were a mathematician, these are names you know. Maybe as a scientist, you will remember the story of the proof of Fermat's last theorem, perhaps one of the most historic events in modern mathematics. That would not have happened without Ramanujan, because a great Fields medalist by the name of Jean-Pierre Serre, who was very frustrated by Ramanujan's idiosyncratic methods for writing down formulas, wanted to fit some of his formulas in the framework of modern mathematics to assist all of us. And out of the course of doing that, he invented an entire language of mathematics called the theory of Galois representations, which is actually the language of the proof of Fermat's last theorem. All of these things would not have happened had Ramanujan never lived. Here, we care about signal processing. This is the science and engineering and mathematics of information and communication, whether it's your remote control with your television, or whether it's your cell phone, or in the future, whether it's two cars in traffic communicating with each other. We need to be able to communicate securely, rapidly, and wipe out errors. So this is what the area of mathematics and engineering that is called signal processing. And my friend P.P. Vaidyanathan, who is at Caltech, won the 2016 IEEE prize for developing a new protocol for signal processing that works at an unusual range of frequencies, bandwidths, that had been inadequate before. And when I met him maybe 17 or 18 years ago, he says, I've got the framework right. It's not Fourier analysis, it's not wavelets. I just need this kind of number theory functions with these like 7 properties. I wish somebody would just give me this. And I remember, and it wasn't me telling them, but others in the field said, you know, Ramanujan in his notebook defined these functions called Ramanujan sums, and the axioms that you asked for are actually on this page, written 100 years ago. And P.P. Vaidyanathan just plugs that in, and he wins the IEEE Kirchhoff Prize. And he feels very guilty about it. It's an example where you're in the right place at the right time to discover that the difficult problem you want to have solved was solved before you even asked it. And that's not unusual. The Ramanujan mathematics is used to study stringy black holes. It's used to study some of the most difficult problems in algebraic geometry and number theory. I mentioned some. If you're searching for K3, you're probably using Ramanujan's formula somewhere, or at least modern versions of it if you haven't gone back to the original papers. So what do we learn from Ramanujan? We see this incredible legacy adding on top of the remarkable human story. So to wrap up with, I only have 2 slides. This is what I want you to think of as the idea of Ramanujan more broadly from the history and the mathematics, because I think this idea speaks to anyone. So I think Ramanujan matters to society because he represents endless curiosity and untapped potential, which we all have to believe in to proceed in the sciences. This is going beyond AI. This is the human part. This is the wonder part, the creative part. These are all skills that AI has yet to display. Probably will never display, in my opinion. Science usually advances on the work of thousands over generations, fine-tuning and extending the scope of understanding. But from time to time, creative fireballs like Ramanujan burst onto the scene and propel human thought forward. That is the story that I want you to take away, at least, maybe perhaps together with some of the other answers I've offered to why he matters. So this is my last slide. It might look very strange. We made this Hollywood film, and you want to sell the film, so we traveled the film circuit. We went to, I won't make a list, but famous film circuits, places where mathematicians like myself don't belong. It was crazy. If you are my Facebook friend or want to be my Facebook friend, you can find me. And my profile picture has me with Stephen Fry, Fields medalist Manjul Bhargava. But in the center of the frame is an actress named Anna Kendrick, who is a very famous actress. That was taken at the Zurich Film Festival, where our film was the opening night film. At the end of that film, we got up on stage and did a Q&A, question and answer session, and she was in the audience. And while I was waiting my turn to be interviewed by the media after the screening, she comes up to me and says, "You're the mathematician guy, right?" Okay, you're like Anna Kendrick. You're like, "Oh my God." Okay, yeah, my daughter wouldn't believe this. Okay, and she was saying, "I'm about to make a film about mathematics, so I really want to talk to you." I'm like, "Pinch me, is this really happening?" Right? And she goes, yeah, we're making a film with Ben Affleck called The Accountant. And then so I had the conversation, and I just sort of had to bite my tongue that being a mathematician and being an accountant, in my mind, are 2 very different things. But it was still very fun. And by the way, actually, that Ben Affleck's character in The Accountant does have some character traits that you might actually associate, unfortunately, with pure mathematicians. So in any event, why did I tell you all of that? What was not so well known for many years, because we kept it under wrap, is that the Breakthrough Foundation underwrote a large part of our project. This is Mark Zuckerberg, Yuri Milner, Jack Ma. They continue to be very strong supporters of science. You're probably aware of the Breakthrough Prizes they give out, and they like to hang out with Hollywood actors if you've seen any of their social media. So at a conference for SETI, the Search for Extraterrestrial Intelligence, funded by Breakthrough, they invited us to screen the film, again, the social activity. And at the end of the screening, there was another Q&A, and I don't know what happened. I had had dinner that night with Jill Tarter, who was the longtime director of SETI. If you ever saw the film Contact, she was the inspiration for Jodie Foster's character. And so I was fascinated to learn about SETI. And at the end of the film, we had that screening, and I guess that conversation with Jill is still in my mind. I said something like this: just like all of you, and there were the SETI scientists in the audience, searching for extraterrestrial intelligence. I said, well, maybe just like you searching for extraterrestrial intelligence, maybe we should be searching for terrestrial intelligence. Why aren't we searching the globe for undiscovered scientific talent? Let's locate and nurture this undiscovered talent. On the way to the parking lot, the president of the Templeton World Charity Foundation came up to me. He goes, "You are so right. I was about to write a check for $500,000 to SETI, but I'm going to give it to you." How do we find this talent? So we've done it. We started a foundation called the Spirit of Ramanujan Talent Search. We have funded 125 people from around the world, I think 32 different countries, who have to overcome remarkable obstacles. And here are two of our first winners. This is a kid we found in Qatar who developed his own formulas for pi. Martin Arungo, he didn't even own shoes, but he was hanging around the math department in the University of Nairobi, helping some of the faculty write their papers. And yeah, so why does Ramanujan matter? I think I offered you many answers. He gives hope to students looking for reason beyond grades and test scores. He represents to government leaders and policymakers the need for international cooperation. For mentors, teachers who need to think about the impact that they play on their students, where they might not exactly understand where their students are coming from. The story of Ramanujan speaks to that. And here, why does Ramanujan matter? Because it meant that to a philanthropist who was in a position to change the lives of the 125 students that we have supported, he felt that was important. One of winners, I'll just tell you, we found her in China. Her parents still want her to just marry some boy in the United States of America. When she ended up coming to MIT, she graduated in 3 years with a master's and a bachelor's degree. She won something called the Morgan Prize, the Schaefer Prize. She then also was named a Rhodes Scholar, and she's now in the PhD program at Stanford simultaneously while she earns her law degree at Stanford. She came from a small village in China. That story alone, I think, is awesome. So thank you very much.
Thank you, Ken, for a very nice talk. Do we have mics in the audience at all? Okay, there are a couple of mics around. Does anyone have any questions for Ken? Questions about Ramanujan? Questions about the foundation? Oh, we have a question over there.
Or making films.
Questions about Hollywood?
Oh.
Thank you so much for the great talk. I have a question. You were talking about how the notes of Ramanujan 100 years back still inspire mathematics today, and that mathematicians still try to understand what he wrote. How do we know that what he wrote is actually true? Sometimes maybe you see something that is very remarkable that you cannot understand. How do you know it is true or worth trying to understand?
Yeah, so there's several things I want to say in response to that. One, based on my 35 years of professor, I mean, this is not like a cult. It's just literally true that if Ramanujan found something beautiful and that he thought was important enough to record in his notebook when paper was so expensive, it's probably my job to figure out what that is and to not seek just confirming that that equation is true or false at face value. I told you equal doesn't mean something different for him than what it is for me, so it can be particularly frustrating. And just like you might be struggling with ChatGPT when it gives you nonsense, it is true when you go and look at the reasoning trace, there's stuff there that is probably true before it begins to make the mistake that could teach you. Maybe I don't want to talk too much about that parallel. So if you linearly go through his notebooks, as some have, and just try to confirm them like check boxes, then I think you would be missing out on the influence of what's really there.
Thank you very much.
Yeah. Yeah. Thank you for staying. Your hospitality is amazing. Yeah.
Thank you for this great talk. I was wondering, why did he have no appreciation for proofs?
Well, he was an amateur. He didn't know you were supposed to prove things, right? In his hometown of Kumbakonam, it's a very well-known city in South India in the state of Tamil Nadu that's overrun. Overrun's the wrong word. It is home to maybe several dozen Hindu temples, and every 12 years, I think like 20 million people descend on this town for their pilgrimage. So everything about his being would have been viewed through the life of a Hindu. So I think, and I have no reason to doubt, that he really believed his ideas came from visions from his family goddess. If your goddess tells you a formula, maybe a proof is unnecessary. I don't know. Yeah. Now, make no mistake, when he got to England, he was a great student. If you haven't seen our film, you'll see that one of the themes through this film is about how Ramanujan learns the need to pay attention to detail, need for nuance, the need for being accountable for your work. And it's a very hard lesson for him to learn, like it is for a beginning graduate student to learn. Right? You can read lots of books, you can read a lot of the words, but that's not the same as how do I translate that into a scientific discovery. Ramanujan was actually very good at making that transition. And in this film, we have a number of scenes that speak to that process. And in the course of writing those scenes, we actually went back to his original notebooks that he wrote in England with Hardy, and I learned firsthand the things that he fundamentally did not understand when he arrived at Cambridge, but certainly understood very well within 2 years. So if you see the film and you see like red markings that were the errors that Hardy allegedly wrote on these notes, I actually wrote them, and they were real mistakes, and it was it was pretty amazing. It was like the extreme and wishful thinking.
Did he gain an appreciation for proving stuff towards the end?
Yeah, well, he at least accepted that to be successful and believed, taken seriously, he had to write down proofs. I don't know whether he felt that was a waste of time or not. Yeah, I know that my typical students, you know what we do in mathematics? We spend a lot of time wondering, but we spend much more time trying to account for what we strongly believe to be true. And among the scientific fields, it's why we have this reputation. You've probably all seen that XCD, right? Cartoon, social scientist, chemist, and then theoretical physics, but then the mathematicians way over here. Part of that is because we often spend a lot of time thinking very deeply about theorems that are always true, that are very difficult to prove, despite the fact we may have other arguments that say 90% of the time at least must be true. And I'm often asked to justify, so why do you do that? Right? If you know with high probability that some claim is going to be true, it's because the edifice of mathematics, when you build it and get the lemmas right, without exception, always opens new doors. And I think, right, when you conduct an experiment and learn something, that's not the end. It just opened up 50 more questions. That's what's exciting, and that's why we insist on that level of detail. And I want people to understand that. Yeah. Yes.
So I'm just, often when you're communicating science, it's almost like the opposite of what you're doing here, which is that you don't want to overstate the significance of your findings. You know, we didn't necessarily find the cure for cancer, but we made steps towards that. Yeah. But here I'm kind of seeing the opposite, that you almost want to just take something that's been understated throughout history and make it bigger. So I'm wondering, how did you balance that throughout writing the book and the movie and your talks later?
This is, I learned through experience, very hard. The very first talks I remember I gave as a graduate student, it was pretty embarrassing. I think it's common, right? You want to talk about what you think is the most important part of the work, and it takes a little bit of experience and maturity to understand and get that right. So, so to answer your question, I think very carefully about what the audience. So I hope you, thank you. I hope everyone else thought there was, at least one of the questions speaks to you. You think about your audience, right? I would give a different talk if this was like Washington, D.C., and there were senators and like the 25-year-old college kids who have more power than they probably should have and think they're smarter than they actually are. So yeah, you have to think about your audience just like you would have to when you write your papers. Science is at risk. Yeah, so I really like that mentoring scene where, and I kind of want to make that point, right? we can't just say that the science we do is important because it's ingrained in us as having to be important. We're at a time where there's a growing lack of faith in science, so it's on us, whether we like it or not, or some subset of us, to champion that. Because the only reason we get to do science is through some democratic process that allows federal agencies to support our work. And I regret to say that, at least in my country, that seems like an entitlement that is now more at risk is being lost. And it's not an acceptable answer to say, don't people know that if we don't do this, people will die? Because that sounds like hyperbole, right? So it's difficult, yeah. And in fact, if you say that, then the people that you want to convince will never listen to you ever again. Yeah.
Hi. First, I'd like to thank you for your great speech. And I'm one of the few non-scientists here. I'm actually a bean counter. And I'm kind of responding to what you just said. The OIST is no exception to some of the funding challenges, where we have such a great institution, but we have a challenge of convincing Japanese government to increase the investment into this institution. And what would be the kind of advice that you can give us so that we can kind of help stir the government to...
Yeah, excellent question. There's several things that I would bring up. The first point that I would make is that this facility is extraordinary. I travel the world, many places. This is almost unparalleled as a facility. So all of the investment that has already been placed into establishing this says that you've already won you've won over important policymakers to see that this institute has been founded. And build on that commitment. You have to have a very strong public engagement department that doesn't overstate things. In science, this is one of the things I hate about some of what we do in the United States in terms of science communications. We too often promote, oh, here is a grant with X millions of dollars, and people focus on the money, without recognizing that at some point you will be held accountable. And in the public, they say, well, where do all these millions of dollars go? Why are all the articles just about, right? And so if we paid a little bit more, we're a little bit more careful about what we do promote, but when we do promote a finding as important, that it justifiably is so. I don't know, I'm not familiar with all of the research programs here, but I think you're in a strong position in this country, certainly a stronger position than in my country, where the leaders of the country are trying to take down science. I certainly hope that's not the case here. And in fact, international cooperation is, in a time of dwindling resources worldwide, is a time for international cooperation. And you know, coming out of COVID, how many of you do a lot of your work online over Zoom with collaborators halfway around the world on a routine basis? A lot of that is easier. I've even learned you can have wet labs here with leaders who are somewhere else around the world, but the experiments are being done here. That's something I learned yesterday, and I think that's amazing. And I think that should be, that's something I would really play up. You got great facilities, right? Do you have to have every member of every team on premises to do great science? Maybe not. Is that okay? I can go on too, right? But also wining and dining people in positions of power and getting to know them a little bit in terms of what their, what their pet projects might be is important. Okay, all right, yeah. Is this okay? Yeah, everybody's really quiet. Maybe we're done.
If there are no more questions, I want to finish with one question back on the Ramanujan topic. So the notebooks, the original notebooks, and then even the lost notebook, the forgotten notebook, how much is still kind of wide open? Like, we don't know if it's true or false. What theory to build on there? Is there still a lot of open?
In terms of in terms of a literal commentary on all of the claims, that has been finished, but I don't think that's acceptable, right? It's something like this. Remember in high school when you learned about sine and cosine, and you remember, oh yeah, 1/2 or square root of 3/2. There's some numbers that are just magically related to sine and cosine, and all of the answers on your high school trig test seem to just only involve those numbers, but the circle isn't just like 6 points, right? I don't know that we're not at that level of gapped knowledge on maybe even as much as 2/3 of the notebooks. Yeah.
So the statements are known to be true or false, but the kind of
why did he care?
Deeper theory around it is still
right. Right.
There.
That's right.
All right. Oh, okay.
Yeah. Oh, I didn't tell you why. My father, I have to tell you, because Okinawa in my mind has this U.S., Japan, World War II theme that I cannot escape from my background. And I told you, I think, at the beginning of this talk that my parents came to the United States shortly after the end of World War II. At the end of World War II, Japan was a defeated country. We know that. And my father wanted desperately to become a mathematician. The universities were devastated. There were no faculty. How did he become a mathematician? It's amazing. And I know the politics, I don't want to get into that, but I can speak to what happened to my family. The United States founded the National Science Foundation. They started having conferences all over Japan in various areas of science. You probably know the ones that were in your areas. They rebuilt the universities, not just the infrastructure of the country. And there was one very famous conference called the Tokyo Nikko Conference in the particular area of mathematics that my father worked in. And basically everyone who was anyone in the world at that time came to post-World War II Japan to teach the starving Japanese students, and they didn't know what to expect when they got here. When they went back to Japan, they probably brought a dozen or so Japanese mathematicians who were literally starving for nutrition, but starving for education, and they took a chance in their lives to leave Japan to start lives in the country they were taught to hate. And you know the story that André Weil, who was the brother of Simone Weil, the very famous philosopher, the story that captured their attention at this conference was in a lecture given by André Weil, where he talked about an Indian mathematician who came out of impossibly difficult circumstances to become important. He talked about Ramanujan. I don't want to cry here, but that generation includes some of the most famous mathematicians in North America. You might know some of the names. They are, like Cole Prize winners, Spring Prize winners. Maybe you know Shimura, Hironaka. Maybe you know Hironaka. He ended up winning the Fields Medal. Kuga. There is someone should write a book about what happened there. And that's why I was so emotional to my dad, because he remembered as a struggling student whether he was going to be able to get a bowl of rice to eat while he wanted to become a mathematician. And the defining moment in his life was when these distinguished American scientists came to help build the schools. And yeah, that's how my life started. And I didn't know that when that letter came in 1984. I was a snotty 10th grader saying, I want to play baseball. I don't give a crap about mathematics, right? I don't care about my SATs, So yeah, sometimes you have to travel a very long way to think a little bit more deeply about why, your question. I had to share that. I hope that's okay, because I know I'm in Japan and I think that matters.
Thank you so much for your very impressive lecture. And I think your lecture was one of the best I heard at this Sydney Brenner Hall.
Thank you.
Yes, really.
Well, invite me back.
Yeah.
I'm going scuba diving tomorrow. I know it.
Oh, so actually my question is related to that. On Thursday, you are going to have a lecture on this data science and swimming training. And so you do skip it. I mean, I just wanted to know how you got involved in this
Let
project.
me save that for Thursday. Let me save that for Thursday.
Okay, sure.
Yeah,
So what time on Thursday?
3 o'clock.
3 o'clock. Thank you very much.
Yeah. All right, thank you.